Import open pit geometry. Reduce the number of faces and the mesh resolution to a more manageable size. Aurora platform allows a maximum file size of 50 megabytes. Add the model components as layers in Rhino. Separate the pit surfaces that form the area of interest. Try and further reduce the resolution of surfaces outside the area of interest. Copy the area of interest surface in a separate layer, and then all pit surfaces as pit stage 1. Try and stitch the boundaries between the two meshes, as holes in the mesh can cause problems in SlopeX. Now we need to extend the boundaries of the wireframe further out. For accurate excavation of the subject pit, a pre-mining topo surface is required. Note the outer boundaries of the excavation steps should be close to the pit crest to avoid a large model size. A waste dump stage is added to demonstrate how waste dump logic is implemented. For large fault surfaces, it is recommended to make two subsurfaces, one which confined around the area of interest and one which contains the entire surface. The smaller surface will be used for meshing in SlopeX, while the larger surface is used for assigning the properties. A closed volume is generated to represent a different rock mass domain. An approximate phreatic surface is generated with an offset of 20 meters from the pit walls. Download and install the Caveric Tools plugin for Rhinoceros from the Caveric forum. Now you have all the files ready in the folder, and you can set up the model using SlopeX interface. Ensure your source file, slopeexamine.save, provided by Caveric, is copied to this folder.